Hello, everybody, and welcome to this very boring class. Uh, we are going to be learning about quadratic equations again because that's very boring, and it, it's all about dying of boredom. Yes, it's all about dying of boredom. That's the purpose of this class, you know. You see here? Okay. Well, anyways, I guess we're supposed to start class, isn't it? So this is going to be the 7th grade curriculum or 8th grade or whatever it is because I really don't know what it is. I'm just teaching you random stuff that you probably never use in your lifetime. It's very nice deal. And this is our title slide. Very fancy indeed. Great depth of building, good palette, and a good amount of weathering as well. Yes, and also a very good amount of vegetation in this build. And the grand scale of it is very good. It's very well integrated into the landscape. Yes, it's a very good build overall. Yeah. Okay, what? We need to start learning about quadratic equations, and today we will be learning about how to solve quadratic equations. And yes, I know. And first, of course, we're going to have to do a review. It's always a review. Very boring indeed. Then we're going to learn about solving quadratic equations and then problems. Yes, very nice. Okay. What the freak? Do I really sound that much like a girl? Okay. I am neither a boy or a girl. I identify as grass. Idiot. Cannot even define me as something. I do not define as a boy or a girl. Not male, not female. I define as grass. Okay. Very nice. So, factoring polynomials. Ax squared plus bx plus c. And this is the type of quadratic function that we are solving today. Actually, it's not a function. Functions are different than equations. So this is what we're going to be solving today. So make sure you know it, because if you don't, you're not going to be able to solve this. And it's very boring in general. I'm just gonna, yeah, I don't even know what to do right here. Like, it's sad, you know. Yeah, this is just very sad. Hold on, let me get out my notes. Where the heck are my notes? Okay, there are my notes from like 3 years ago. Ax squared plus bx plus c. Very good. Okay, I found the section. So our example is once again 25x squared minus 65x minus 30, but really don't need a new equation unless you really want one. Just going to review the material. And the chat has exploded again. Well, not really, just three comments on yes. Okay. The teacher's most used phrases. People, yes, very nice. Indeed, yes. This class is very boring indeed. Okay, just seriously. The last one, you missed it. Okay. No. This class is very boring indeed. Okay. You see, the mistake is that you added a comma. Okay. The comma is the problem. I don't use a comma in my sentences. It's this class is very boring indeed. It's not this class is very boring indeed. I never say that. Well, I just did, which is just sad. Yes, can we learn already? Yes, of course. Wait a second. When did Edward want to learn things? Wow. Well, that's a revolution. So, factoring polynomials. Let's get going. So, first of all, what's the first step of ax plus bx plus c? Can anybody tell me what's the first step? Okay. is the first step of solving ax squared plus bx plus c? What is the first step? Hopefully you took notes, because if you took notes, then you would memorize this. Or if you have just really good memorization, then you would still memorize this. For those who are actually paying attention to this class and not being stupid and playing Minecraft over there. Actually, playing Minecraft is not stupid. Playing Fortnite is stupid. Just, yeah. So, what's the first step in factoring ax squared plus bx plus c? Seriously. Okay, so this is very disappointing. Yes, very disappointing. Okay, Maggie is actually the closest one because she's the only one that answered. This is just sad. Okay, so this is okay. There's one part that is vaguely similar to what I'm supposed to say. It's the AB plus AB part. Okay, that's called the split B. So first of all, what are we supposed to do? We're going to multiply AC. Okay, AC is the first step. Okay, AC is the first step, and then we are going to, and let's see, AC is going to be 25 times negative 30. Okay, put that in your calculator. Let's see. Negative 300, negative 755, 50, negative. Okay, this is just sad. Negative 750. Okay, I think. So next we have, next what we're supposed to do is we're going to find two numbers, okay, that multiply to negative 750, and then those two numbers also have to add up to 65. Okay, so where are the, okay, so what are two numbers that multiply to negative 750 and then add up to negative 65? That would be negative 75 and negative 10. Okay, okay, this is very, very unorganized. Yeah, let me just do second step. Okay, going to be negative 75 plus negative 10 is going to be equal to, what the frick? Okay, that's plus 10, not negative 10. Plus 10 is going to be equal to negative 65, and that's going to be, multiply that, okay, multiply is going to be equal to negative 750. Next, we're just going to rewrite our equation right here, or expression, not an equation. Okay, and it's going to be like this. And as you see Maggie's format that she gave us, you split the B into two parts. Okay, and next we're just going to factor by grouping. Hopefully you know how to factor by grouping. Okay, so let's take this formula, or what kind of formula? Okay, I cannot speak today. Surprising, new info. Yes, it's just going to be, let me show you what factoring by grouping is, in case you didn't know and you didn't pay attention in the previous classes where I actually taught factoring by grouping, and you can't actually do anything, and you're not even paying attention to this class, and I'm just sad over you. Okay, this is what. So let's actually solve this instead of being crazy. So separate it into two groups. Okay, hence the name, factoring by grouping. If you cannot figure that out by the name, then something's wrong with you. And basically take the greatest common factor out of each of these groups. Okay, factor it out, and it'll be like this. Let's see. Okay, just like that, we factored out the greatest common factors, and you see this part, it's the same. So you can just simplify to this. Okay, that's going to be our answer. That's how you factor ax squared plus bx plus c. Next, we're going to quickly review graphing. Oh my god, that's a lot of stuff. I might cut this review short because of our time issue. No, I'm not going to cut it short. Of course, why would I cut it short? I'm just going to torture you guys with a long review. Yes, it's a very fun thing to do when you're the teacher. Okay. So, introduction to graphing. Very nice. So, of course, our simplest form is just going to be y equals x squared, because what is our simplest quadratic that we can have? It's going to be something squared. It could be y squared, or it could be x squared. Okay, any variable squared. But when we're graphing, we're going to focus on y and x and z. Okay, z, we're not going to focus on that yet. Learn that in geometry or something like that. Okay, we're going to focus on, since this is a two-dimensional coordinate plane, we're going to focus on y and x. Okay, so the simplest form is going to be y equals x squared, in which case just be a parabola. Okay, not a parabola, a parabola. Pronunciation issues. Okay, so basically, when we're graphing, we're going to have a parabola, okay? And that is basically a U-shaped graph. And sure, you already know these, so I'm not gonna take the time to write out each of these. I'm just going to talk about it for a bit. Okay, so let's see. Okay, so a parabola is going to be, so here's the vertex. There's always a vertex, and that is basically the lowest or the highest point on your parabola. Basically a U-shaped graph here. You can see it kind of extends from this vertex here. And what is this drawing? Okay, that sucks. Well, this is going to be the vertex. Make sure you have that. And sometimes it's facing downward. It can face upward, or it could be an upside down U. Okay, in which case this would be the vertex, and it would be the highest point. Okay, and this vertex is going to be the lowest point. Okay, and when you have a vertex that is the lowest point, it's called a minimum vertex. And when you have a vertex that is the highest point, it's going to be called a maximum. And of course, we have our axis of symmetry, which, okay, let me just trace this graph real quick. Too messy. Let's draw another one, and let's say we have something right here, okay? And our axis of symmetry would be right here. And even though my drawing is very bad, and it doesn't really look like it's symmetrical, but parabolas are always symmetrical. So there's going to be an axis of symmetry in the middle of this parabola, and that's going to be essential when we're graphing graphing the function, okay? Okay, so How do you decide if the U shape is facing up or down? Okay, that's a very, very good question. And good job noticing that. So basically, when I was first introducing this how to graph, okay, I was explaining, you see here, we have the values A, B, and C, right? And to determine if a parabola is like facing down or up, we need to look at the A value. So the A value determines, most of all, it determines the width of our parabola. So I can make it skinnier or wider or whatever. And when A is positive, it's going to be like this. Okay, when A is positive. When A is negative, it's going to be like this. Okay, so it all depends on the A. And the greater A is, the skinnier it's going to be. If A is like 1, it's going to be like this. Okay, if A is like 10, it's going to be like this. But we really don't know, we really don't have to worry about the A when we're graphing, because when we're graphing, we have some steps. I'll talk about that. So let me talk about the graphing steps. So once you're graphing, you get after you find like you're supposed to find the AOS first. Okay, so the first step is finding our AOS, okay, which is the axis of symmetry. And we use the formula negative b over 2a. Okay, now explain how we determine if a parabola is up or down later. Okay, I think that would be, yes, that'd be like, that'll be in step 3. Okay, so we need to find our AOS. Is basically the x value of our vertex. Okay, so let me just draw a graph over here, and the AOS can be over here, it can be over here. It's basically the x value of our vertex, because our vertex is going to be somewhere on this AOS. So our first step is going to be to find our AOS, and in this case, we use x squared minus 6x plus 4. Okay, that's going to be our example. And you see here, this is the b value. It's going to be negative 6. Okay, it's not just 6, it's going to be negative 6. So negative, negative 6, two negatives, that makes a positive. And a is just 1 right here. So it's just going to be 3. Okay, so it's going to be at 3. And that's our AOS. So number 2, we're going to find our vertex. And how do we find our vertex? We are going to plug our axis of symmetry into our equation. Okay, so it's going to be an ordered pair, right? We already know the x value because the x value is basically 3. So let's put that in real quick. And let's just substitute 3 into our equation. So it's x squared minus 6x plus 3 plus 4. So it's going to be 3 squared minus 6 times 3 plus 4 equals negative 5. Because 9 minus 18 plus 4, okay, this is going to be negative 9 plus 4, negative 5. Okay, so our vertex is going to be 3, negative 5. Third step, let's graph our vertex real quick. Should help right here. Step 3 is going to be finding 2 points that are close to the AOS. And once you find these 2 points, you can determine if it's facing up or down. Okay, so let's just find 2 points that are really close to our AOS, 2 integers, because they are easier to work with. So let's make our little graph here. Usually you need 2 points, okay? Not just one, okay? You need 2 points to fully grasp how the parabola is gonna work. So, what are 2 points close to 3? Let's pick 2 and 4. Okay. So, actually, 4 is a bit big, so let's just choose 1. Okay, and we're just going to plug these points into our function, substitute them as x, and get our y. So, let's start with 2 right here. It's just going to be 4 minus 12 plus 4. It's going to be -4. And 1, plug 1 into our equation. 1 minus 6 plus 4 is going to be -1. So let's just graph these points right here, and we'll be done after we're done. Yeah. After we're done graphing, right here. So these are our 2 points, and this kind of makes this, okay? That's not a U, that's not a parabola. And using our axis of symmetry, find 2 more points that are like symmetrical to our first 2 points. And using our axis of symmetry, you can kind of guess where they are, right here. And you can get a U shape. Mine isn't really a U shape. If you use a graphing tool like Desmos, you can actually see what it actually looks like. Of course, there are arrows at the ends because it goes on forever. And so the parabola kind of looks like this, okay? And you can tell from my graphing skills, okay, it's not exactly on like point. It's not exactly perfect, but you can see the A here is positive, right? The A here is positive. The A is 1, so of course it's going to be up. And let's say, what if the AOS? I mean, what if the A was negative? Then you might find points like, let's say, this 2 right here might become a -1, and the 2 more points that you find could be like right here, and then you'll know that it's going down. So that's how you find it out once you find those 2 points. Or you could just directly look at the A. It's much more efficient. You can see, is it going up or is it going down? And that's a pretty good way to find if your answer is correct, because if the A is positive and you know that the parabola is going up, then, and if you get an answer that's going down, then you know you're wrong. Okay. So, uh, so has everybody died of boredom yet? No? Okay, so with let me entertain you with a conspiracy theory, okay, that I've developed. Over okay, the past over the past month, schools have been closing down. You know why? He said those schools are closing down. They're closing down. They're closing down. Okay, and you might think this is due to the disease called, scientifically known as COVID-19, more commonly known as the coronavirus. Okay, and this disease, COVID-19, causes a a virus called SARS, and SARS previously plagued the U.S. and China in 2003. It was called SARS-1, and this new virus is called SARS-2. And COVID-19, okay, don't mistake COVID-19 and SARS-2. They're different things. COVID-19 is the disease that causes the virus SARS-2. And SARS-2, SARS, is severe acute respiratory syndrome 2. Okay, it causes damage in the lungs. Okay, like shortness of breath, fever, that kind of stuff. You might think it isn't a pandemic that has raged through the whole world. It is very, very severe. You might think schools are closing because of this, but no, they're not closing because of COVID-19. They're closing because people are dying in schools. No, but not because of COVID-19. They're dying because of another disease. Okay, COVID-19 is just a cover-up for another disease. It's called the neurological boredom disorder. It's called the neurological boredom disorder. No, let's change that. It's called the neurological boredom syndrome. Okay, I have no idea what syndrome means, but that sounds cooler and more scientific and more smart, so let's use that. So it's called neurological boredom syndrome. Let's say there's so many subjects in school, and most of them are pretty boring. Let's say science, biology, motion, flight, chemistry, physics, boring stuff. Writing, reading, English language arts, reading analysis, reading comprehension, essay writing, very boring indeed. Mathematics, what's there? Geometry, algebra, all this pre-calculus stuff. Very, very boring indeed. And social studies, history, U.S. history, world history. It's very boring stuff. So school is kind of boring, okay, to be truthful. But school is a very good place to be educated and be learning. But you see, people are dying of boredom in schools. Okay, this is a kid. Let's just name him Fred. Okay. As you can see, my drawing skills have gotten better. Look at him, so handsome. So he's going into this classroom. He learns mathematics, learns all this stuff, and he's bored. Okay, and because of this boredom, soon he is in the hospital dead. Okay, poor little Fred over here, and there are so many dead bodies here. Okay, so that is why schools are being closed. Very fancy way of saying it. It's called the neurological boredom syndrome. Honestly, I'm just trying to waste time here because the subject can't even like. What am I doing here? Anyways, hopefully that made you less bored. So let's start actually learning the subject for today. What the? Okay, so a website. Wombat. What the? Wombat. What the hell is this? Oh wait, I'm not supposed to use the H word here. It's supposed to be a friendly class. Very interesting story. Yes, exactly. Very interesting story. Yes, so good. I mean, like, totally not bored. No. What are you doing? Yes, wombats didn't make wombats didn't make COVID. Bats did. Bats made COVID. That's a conspiracy theory. Yes, and other animals made COVID. Yes. Eh, you see, the coronavirus illness has resonated in like in animals for many years, and then somehow it got into the human species. Either someone forgot to wash their hands when they were taking a piss, or someone just was very bad hygiene. That's how. Totally. Why do students not die in online class? Oh, they die every day. You know how some students don't turn on their cameras because they died. Yes. So, quadratic equations, we're actually trying to learn something here. And yeah, I would appreciate if you guys stopped rambling on about random stuff. And yes, you, not me. I am not rambling on about random stuff about coronavirus. Okay? You're rambling on stuff. Geez, kids nowadays. Okay, so first of all, when we're trying to understand quadratic equations, it's going to be an equation. Okay? So let me just. Okay, so what is a quadratic function? Okay, can anybody tell me what a quadratic function is? Okay, what is the form for a quadratic function, and what is the difference between a quadratic function and a quadratic equation? Okay, let's first understand what's the difference. Okay, so what's the difference between a function and an equation? Okay, does anybody know? Oh, why aren't you dead? Let me just see. Check the participants. Kaisi hasn't said anything this whole time. Eric hasn't said anything this whole time. Genevieve hasn't said anything this whole time. I wonder where they went. Unless they're just playing Minecraft in the corner, then that's an excuse. Oh, never mind. Genevieve says something. Okay, the world ended. Okay, yeah. So, let's first understand the difference. So, a quadratic function, we need a y value. Okay, we always need a y value when we're graphing. Y and x value. Okay, so the quadratic function will be y equals ax squared plus bx plus c. And a quadratic equation is going to be ax squared plus bx plus c equals 0. Okay, they're different. Okay, quadratic functions, you can graph them. They really can't be solved because there's two variables. Okay, and there's only one equation. You can't solve that, even with like systems of equations. You're not supposed to solve them. You're supposed to graph them. Okay, and usually, if you don't graph them, basically a function is something you have an input and you have an output. Okay, recall when I was teaching you guys about functions. Okay, our functions class. Well, that was way back when. Okay, so we have an input. Let's say we have 3 as our input. Okay, and you have 3. We put that into our function and we substitute that with x. Okay, and then we get a y value. Okay, so that's the point of a function. An equation, you can graph it as well, but the main point is to like solve it. Okay, you can actually solve this. There's no like an input in it, because if you put an input in it, if you put 3 in it, then it's going to be like all numerals and stuff. You're not really going to solve what x is equal to. So, first we need to understand what types of solutions there are when we're solving quadratic equations. Okay. Ooh. So there are 3 solutions actually. There are 3 solutions. And usually, okay, quadratics have 2 solutions. Okay, they have 2 solutions. Now, first, before I talk about the types of solutions, let me give an example. Okay, so what is, okay, this is an example equation. x squared equals 16. And I'm just going to give you two. I'm going to give you two warm-up questions before you talk about solutions. Okay, so can anybody tell me the answer for these? I'll give you 2 moments. Okay, so let's see. Okay, the first one is 4 and the second one is 3. Very good. Jason, you got one part incorrect. Okay, and almost everybody gave me a correct answer, but only Edward got me a correct answer because it's not just 4. It can be -4 as well. Okay, so the answer is going to be 4 and -4 and 3 and -3 because -3 squared is still 9. Yes, Pog. Very nice. So you see here, what are we supposed to do? We're going to square root. And we can get plus minus 4. Okay? And plus minus is basically when the answer can be both 4 and -4. Okay? And same thing here. Moves the 9 here. Okay? X equals plus minus 3. Okay, so as you can see, most of these quadratics have 2 equations. 2 equations. Okay. Okay. So now we know that most equations have two okay, what the frick? 2 solutions. Now that we know that most equations have 2 solutions. Okay. Let's look at other solutions. Sometimes we have one solution, okay? Sometimes we have one solution. And sometimes we have 0 solutions, which is just no solutions. No real solutions. Okay, so let's look at 3 graphs right here. And our solutions will be x, right? X is our solution. Basically, one way we can solve by graphing. Okay, remember when we were solving for systems of equations, we could solve by graphing. Okay, systems of equations we could solve by graphing. So normally, here's a parabola. There are 2 x-intercepts. Okay, two answers. Okay, and then 2 solutions. Okay, what the frick is this handwriting? 2 solutions. 1 solution. Okay, and 1 solution is when 0 is the solution because there can't be -0, there can't be +0, it's just 0. And basically when the vertex is on the origin of the coordinate plane, or not the origin, it can be here as well. Basically when the vertex is on the x-axis of the coordinate plane, then we have 1 solution. What if it doesn't even touch the y-intercept? The x-intercept, I mean. There's no solution. There's no solution in this case. Because it doesn't even touch the x-axis. So there would be no x-intercept, no answer. So that's no solution. But most of the problems we're doing today have 2 solutions. Okay, and one solution is when 0 is when 0 is x, and that's relatively rare, but still keep an eye on that. So method 1, how to solve, we can solve by graphing. Okay, so let's do x squared minus 2x minus 3 equals 0. Okay, let's solve by graphing. Let's graph this thing. Then we can find our x-intercepts. And then we have an answer, right? First step, AOS. What's our AOS? Okay, that's going to be 2 over 2 times 1. Negative b over 2a. Our AOS is going to be 1. Okay, vertex. X is vertex. Okay, so let's just substitute our AOS into this equation. Okay, it's going to be negative 4. 1, negative 4. So next we have to find 2 other points. And since we already know how to graph, this will be relatively easy. Let me get our coordinate plane ready. Okay, so our AOS is 1. Vertex is negative 4 right here. And what are some points that are close to 1? 0 is 1, negative 1. So basically, if you plug 0 in here, it's going to be 0 squared. 0 minus 0 minus 3. It's going to be negative 3. Okay, plug negative 1 into here. It's going to be 1 minus 2 minus 3. I don't know. Never mind. Forgot to plug this in. Okay, so it's going to be 1 minus plus 2 minus 3, which is just 0. Okay, so then we're just going to plot our points here. Okay, and you can do the same for the other side. And see, we have a parabola right here. And our 2 solutions are our 2 intercepts. And our solutions are, we have negative 1 and 3. Okay, so that's going to be our answer. Moving on. Our second method is much more easier. However, you can only do this when we are solving for a binomial. Okay, it's kind of hard to use square roots when we're solving with trinomials, the standard form of quadratics. Okay, then you'll probably have to use factoring or the quadratic formula. We'll talk about that next class. 3x squared minus 75 equals 0. So this is our example. Of course, this is quite easy. What you're going to do is just move 75 here. Okay, divide by 3 on both sides. X equals plus minus 5. 2 solutions. Okay, and that will be it for this one. But be mindful of one thing. If this is a plus sign, okay, if this is a plus sign, you don't even need to look at this. No solution already. It's already no solution. Okay, and once you see a plus sign, okay, Get rid of it. It's no solution. Why? Because you just need to do the first step, okay? Do the first step. Okay, do the first step. Do the first step. Negative 75 on this side. Okay, and you see here, you need to. There's a square right here, and to get rid of that, you need to take a square root. Okay, and you just take a square root of negative 25. Okay, that's not going to happen. You can't take a square root of a negative number. It's not going to happen. Well, you can't take a square root of a negative number. It's going to be I. Okay, it's an imaginary number. You learn that in algebra 2. It's going to be I. Okay, let's talk about that later. Too complicated to explain right now. So be mindful of no solution. In this case, just no solution. So now let's move on to our practice problems. Okay. First step. First problem. I'll give you a few moments to solve. Yes. I'm just gonna be here drinking extremely sour lemonade. Voila. Wow. Too sour for me. Why am I still drinking this? Okay, let's just. Okay. R squared equals 49. Are you sure? Are you sure it's not negative 49? Because then there'd be no solution. There's Edward. Very nice. No solution. See here? You have a plus sign. See the plus sign? No solution. Don't even need to solve. Bye. No, actually. Let me explain it. Why is no solution? Move negative 98 to here. Okay. Divide by 2. R equals 7i. Yes, it equals 7i because I is the square root of negative 1. Okay. That's going to be an algebra 2. Let's not worry about that. It's going to be no solution. Because you can't take a square root of take the square root of some negative number, so it's just going to be no solution. So, number 2. Solve this with the square root method. Or you can solve this by graphing. Either way, you'll get the correct answer. So, negative x squared equals 3. Okay, that's correct. Yes, and then Edward says it's still no solution. And Jason says it's around negative 1.7. Okay, Wombat and Jason, you're both wrong. Because of sign. Your sign is wrong. Still wrong. Negative 1.7 and 1.7 are the same thing because they both square to 3. It's going to be no solution. See here. Negative x squared. Okay, negative x squared. Let's just move 3 here. Okay, negative x squared equals 3. There's a negative 1 here. Divide by that negative 1. X squared equals negative 3. You can't take the negative square root. It's going to be no solution. Why the heck did I make 2 questions that were no solution? Okay, that's it. So, yeah, well, that was our last problem. Thank you for listening. And of course, I chose this mansion, this Minecraft mansion, that completely pales in comparison to this first one. Literally, like, this first one is so pog, and this other one is like, oh my god, why did I choose the one? Ugh. And it's all like oak wood, bro. Like, what are these glass paintings? There's big windows, and okay, at least add some style to your windows. And what are these fences? They're like all brown and stuff. You need to integrate more cobblestone in this one. What's that smooth stone doing here? What the heck? You got some stone, you need to weather it. Oh my god. What the heck is this terraforming? Oh my god, what is this terraforming over here? Okay, this is just sad. Okay, yeah, I'm done with this. Yes. Okay, so yes, thank you. Yes, you're welcome. And I'm just going to. Oh yes, for our face reveal. Face reveal. Okay, time for another face reveal. I'm all set. Yes, here I am again. And just so you know, I did not wear this mask for the whole time. I totally did not wear this mask for the whole time in fear of accidentally turning on my camera. Yes, totally. Yes, very nice. How the heck am I a girl? The frick? Okay, this needs to end. So, yeah, okay, I'm out of here. What the frick? Can I not end this meeting? Wow.